So, good morning, everyone. So, we are discussing with data structures. We are discussing module 3, that is linked list. So, in the previous class and all, we have gone with a stack implementation using linked list, and then you have gone with a queue implementation with linked list. So, that concept we call it as linked stacks and queues. So how you work the stack using linked list, we call it as linked stack, and stack using queue using linked list, we call it as linked queues. So that when we consider it as linked stacks and queues, now you come for the last topic of the module 3. So we are discussing with last topic of the module 3. So that is two topics are there. One is polynomials using linked list. The other one is sparse matrix representation using linked list. So polynomials using so so linked list, we have two applications of the linked list. So if they ask you application of linked list, so application of linked list, then you have to answer this two. So which are the applications of the linked list? One is polynomials using linked list. The other one is sparse matrix representation using linked list. So it is one of the last topic of your module 3. Okay. So now we shall see why you are going with a linked list. So you can use array for the polynomial representation. So you have a polynomial representation, you have gone with a CCP lab only. So binomial coefficient, find the coefficient of a polynomial using array only we have seen. But there is a disadvantage of using array. So in order to overcome that disadvantage, we are going with a linked list. So that is the concept. Polynomial using array. What is the problem? Now we shall see. So now you consider a polynomial of 16x to the power 21, 3x to the power 5, 2x plus 6. Okay, so this is the representation. So 16x to the, so this one you can consider it as, so you have to consider it as power. Okay, so that we have to see. So this is x to the power 1 and 6 x to the power 0. So this one is the polynomial we have taken. Okay, so in order to make the changes for that, now you are going with a array representation. So first you see here, array will start with location 0. So this is array location 0, you see 6 is the coefficient and 0 is the power. So 6 is there, so power is not there. Now you come for here, only 2 is given. 2 is the coefficient and 1 is not represented. So that is x to the power 1 is not there. Next you see x power 2 is mentioned as 0, x power 3 is mentioned as 0, x power 4 also it is mentioned as 0. Now you see x to the power 5, it is given as minus 3 after x to the power of 5. So are you finding x to the power 6, 7, 8, 9, 10 and all? So you can answer in the chat box. Have you finding after x to the power 5, are you finding x power 6, 7, 8, 9, 10 and all? Are you finding? Yes. Are you people there? Can you answer me? X to the power 0 is there. That is x to the power of 0. We have 6. X to the power of 1, we have 2. X to the power of 2 is not there, it is 0. X power 3 is also 0. X to the power of 4 is also 0. X power 5, we are having minus 3. So after x power 5, next what is the power you are having? It is 21. So that means from x power 6 up to x power 20, you will be having all the zeros. So next x power 21, we have 16, understanding? So that means it is going to lead a lot of space. So the lot of space are mentioned with 0. So this causes waste of space. So that is the problem of using array using polynomial. Okay. So if there is if there is a difference in powers in large number, so what you will do, for all the numbers you will be putting it as 0. So that leads to waste of space in array. Okay. So now you come for the polynomial linked list representation. So how you represent using linked list? So polynomial will be given as a of x. So a of x is the polynomial. So in that we are giving it as coefficient. Next will be the exponentiation. Okay. So coefficient we call it as a, and exponentiation we call it as e. Okay. So first coefficient we take it as a m minus 1, e m minus 1. Next coefficient we take it as a, and exponent is e. Similarly, the last one we take it as a naught is the first coefficient, and e naught is the first e naught is the first exponent. Okay. So that representation using linked list we consider like this. So struct polynode. So polynode is nothing but the node. Okay. So in that you are finding two variables. One is a, the other one is e. So a is called as a coefficient and e is called as a exponent. Okay. So that's why we take it as int coef. Coef means coefficient, and int exp. Exp is nothing but exponent. So coefficient is nothing but a, and exponent is nothing but e. Okay. So now you see here each and every field will should consist of a linked list. So linked list means, so first it should point to next coming. So this is the first node. So inside first node, first coefficient, first exponent. Next we have link field, next field that contains the address of the next node. So that's why we are given it as polynode star next. So star next coefficient is also the data, exponent is also the data, and along with that we have the pointer, that is next pointer. Okay. So first that is the coefficient a, next is exponent e, and followed with the next pointer. So next pointer will contains the address of the next node. Okay. So it contains the address of the next node. So in that, now you take this example. So 3x power 14 to x power 8 plus 1. Okay. So first we have 3. 3 is the coefficient. 14 is the exponent with the next pointer. So this is the next pointer which points to next node. So under next node you are having 2 is there. 2 is the coefficient, 8 is the exponent with the next pointer. So next pointer is now pointing to the next. Next you are having only 1 x to the power 0. So keep this one in your mind. 1 x to the power 0, that we call it as 1, 0 and null. So why null? Because it marks the end of the node. So it doesn't come pointing to anywhere. That's why we represent it as 1, 0 null. So similarly, you take this example. What is first coefficient? Coefficient is 8 and exponent is 14. Next you come for next one. Next coefficient minus 3 and exponent is 10. Next you come for 10 and 6. Okay. So this is the representation of linked list. Polynomial using linked list. Okay. So now you come for this representation. So here I have taken two polynomials P1 and the next one is P2. Okay. So how you represent the same what we have given here, that we represent the same thing here. So first to come for P1, as I've already told you, it will consist of how many fields? So it will consist of three fields. One is coefficient, exponent, and next pointer. Now you come for this one. So first coefficient is 23 with exponent 9. So that's why we give it as 23 and 9 here. So next coefficient 18 with exponent 7, 18 and 7. Next you come 41 is the coefficient and x power 6. So that's why we call it as 41 and 6. Next you see here it is 163 with 4. So the small change. So here you should get 163 with 4. So finally you see you are having 3. 3 means x to the power 0. So x to the power 0 means 1. So that's why we take it as coefficient is 3 and exponent is x power 0. So x power 0 we take it as 0 here. Okay, so finally we make this one as null. See this one, this is the representation of null. So here you can represent the using the same thing. In box you can write null, or you can make like this representation also. So now you come for the second example. So P2. So first coefficient 4, exponent 6. Coefficient 10, exponent 4. Coefficient 12, x is there means x power 1. So that's why we give it as 1. Next 8 with power 0. Okay, so this one it is a pointer and this is the node. So no, this is the node, we call it because it consists of data. Which are the data you are having? One is the coefficient, the other one is exponent. Okay, so this is the type. Are you getting? Are you getting? It's very important for the exams. So now you come for adding, now you come for adding the polynomials. So how you add the polynomials? So for that you have to consider two polynomials P1 and P2. So first polynomial is P1, second polynomial we consider it as P2. So adding of polynomial, adding means it is we are adding, it is a binary operation which requires two operands. So two operands are P1 and P2. Okay, so to do this you have to understand this concept. Okay, so now you consider this one. This one is P1 and this one is P2. So kindly understand carefully here. So if power of P1 and is greater than power of P2, so power of P1, if it is greater than power of P2, keep P1 as it is. If both the powers are same, then you go for addition. So that I will tell you in this. If the exponent, that is power of P1 is greater than P2, copy the node of P1 to end of P3. Okay. Similarly, if the exponent of P1 is less than P2, so if it is less than P1 power is less than P2 power, copy node of P2 to end of P3. Understanding? So this is the concept. If P1 power is greater than P2 power, add P1. If P1 is lesser than P2 power, then add P2. If exponent of P1 is equal to exponent of P2, so create a new node in P3 with same exponent and the sum of the coefficient, so that you will understand in this particular example. So see here, so this is the input. So input we are taking 2 and you are getting the output. This one is output. Understood? So similarly, this is also an output. So come for input 5x square 4x1 2x. So here you are having 5x1 plus 5x0. So now you see P1 and P2. So are the both the powers are same? So here it is x square, here it is x. So as if we are having different numbers. So if the power are not same, then put the greater one here. So keep in your mind 5x power 2, 5x power 1 can't be added. So you put 5x power 2 as it is. Now you see which one can be added? 4x power 1 and here 5x power 1. So 4x and 5x can be added. So that will be given as 9x power 1. Okay. So similarly here 2x power 0 and 5x power 0. So as degrees are same, exponential powers are same, you can add. If there are different, you can't add. So 2x power 0 plus 5x plus power 0 will be given as 7x to the power 0. So that now you come for the another example. So 13x power 8, 5x power 5, 32x square plus 54. Okay. So now you see 3x power 12 and this is the range. Okay. So now you add 8 with 12. Can we add? So you can only add when both the powers are same. Okay. You can't add if the powers are different. So first, which is the higher power? So that you write down. So here in this, 3x power 12 is higher than. So that's why we give it as 3x power 12. So next you see 13x power 8. Anything is there to add? No, it's not there. So that's why we take it as 13x power 8 as it is. Now you see here, it is 7x power 15 and this one is 17x power 15. So both the powers are same, so you can add. If the powers are different, you can't add. If the powers are same, you can add. So 7x power 5 plus 17x power 5. You can add it, so you get the result as 24x power 5. So next you get 32x square plus 3x cube. So here are you finding anything? No. That's why you write it as 3x cube as it is and 32x square also as it is. So now you come for the last one, 54. This one is 98. 54 plus 98 will result in 152. So now have you got understood this, how you add the polynomials? So now answer this, 13x power 8 plus 5x power 3. Can you add? So 13x power 8. So this one is x power 8 and 5x power 3. Can you add? Answer for this. No. So if no, why? If no, why? Tell me the reason. Why you can't add? Because x powers are not same. Okay, good. So you can only add when the powers are same. If the powers are different, you can't add. Okay, good. So now you see that is the representation. So list one, you take it as If this one you take this example, I have represented like this. So 5 is the coefficient, 2 is the exponent with a link pointing to next one. 4 is the coefficient, 1 is the exponent. Next you have 2 is the coefficient and 0 is the exponent. So now you come for the P2. So under P2 you are having 5. 5 is the coefficient, 1 is the exponent. Next 5 is the coefficient, 0 is the exponent. When you add, you see 5 and 2 will result in, here you see both are having powers as same, that is you are having the powers as 1, so that's why you keep it, add these two coefficients, that is 4 plus 5 will result in 9. Next you see these two are same, so when you have these two are same, so you can add this, this 2 plus 5 will result in 7. Understood? So now you come for the programming part. So this is the program you can easily write down. So this is the program you can take. So first we will write the function. What is the function name? Polyadd. So polyadd is the function we can take. With how many input variables? One input variable is P1, the other input variable is P2 with a one output variable result. So because you are adding two polynomials, so first polynomial is P1, second polynomial is P2, and finally you get the result as third added one as the result. Okay, so first you start with P1, then next, and P2, then next. Okay, so now you come for the condition. So if P1 power, so this is very important one. So I will tell it very clearly, kindly you can understand easily. So first, totally you have how many conditions? So three condition, P1 greater than P2, P1 less than P2, P1 equals P2. So all three things you are taking here. P1 P1 power is greater than P2 power. What you will do? If P1 power is greater than P2 power, what you will do? You will add P1 to the result. Which is the greater one you are having? That one you will add to your result. So what is the result? So result then power is equal to P1 then power. Result then coefficient is equal to P1 then coefficient, and P1 will point to next. Understanding? So if P1 is less than P2, what is the case? So you will consider P2 now. If P1 is greater than P2, consider P1. If P1 is lesser than P2, consider P2. So result then power is equal to P2 then power. Result then coefficient is equal to P2 then coefficient. Similarly, P2 then next. Now this is the first case. Second case, come for the last case. So last case is which one? Exponent of P1 is equal to exponent of P2. So when you come for last case, what you will do? When you have both same, result then perv is equal to P1 det perv. So next result then coefficient is equal to P1 then coefficient plus P2 plus coefficient. So this is the logic for adding coefficient if powers are same. Adding the coefficients. So when you will add the coefficients? When both the powers are same. So at that time you add the coefficients. So when you add, so you have to move to the next node. So you have to move to the next node. That's why we take it as P1 is equal to P1 then next, and P2 is equal to P2 then next. Okay. So now you come for the last one, result. So once you find the result, so first you allocate the size, next you take it, result is equal to result then next, and result then next should point to what the result then next. So this is the result. Result is equal to result then next. So result then next will always point to the null variable. Okay. Now again you come while P1 then next or P2 then next. So now you have to write it for P1 and P2. Okay. If P1 then next, again you copy the same thing, no change in that. So if P1, then next, what should be done? Where you consider P1? So here you are considered P1 and here you are considered P2. So P1, then next. So this is for, so adding next nodes. So if you had the next coming nodes, so that's why we take it like this. P1 then next. So what you should do, result then power is equal to P1 then power, result then coefficient is equal to P1 then coefficient, and P1 is equal to P1 then next. So what you have written, the same thing, you will write it here. No change in that. Understanding? So what you, if P1 then next, what you will write? So what you have written for P1 greater than P2, the same thing will come and sit here. So it is same as P1 greater than P2. So same code. Similarly, P2. So similarly, you come for P2 then next. So where you consider P2? When P1 is lesser than P2. So when P1 is lesser than P2, now you see you consider P2. So P2 then next should be taken as result then power is equal to P2 then power, result then coefficient is equal to P2 then coefficient, P2. So this is same as P1 lesser than P2. Okay, so this one you take P1 lesser than P2. Okay, so finally you add this particular line. So this is the line what you have added here. Result then next is equal to, you allocate the space and make it to next and make it null. So this is for adding the polynomial function. So now you see, after adding, now you come for the university question. So this is the university question we have taken. What university question they have asked on polynomial, that is write a C function to add two polynomials represented as circular list with a header node. Okay, so this is for adding the polynomials C function as a circular list. So add node head 1, that is P1, node head 2, that is P2, and node head 3, that is resultant. Okay, so take the same thing. A is equal to head 1 then link, B is equal to head 2 then link, because head 1 is nothing but what? Head 1 is nothing but P1, head 2 is nothing but P2. So what you will do, if A exponent is equal to B exponent, if both A exponent double equals B exponent, what you will do? If both the powers are same, what you will do? Coefficient is equal to A then coefficient plus B then coefficient. If coefficient not equal to 0, what you will do? Head is equal to coefficient A then exponent head 3. So head 3 is nothing but, so you can tell it head 3 is equal to result. So keep this one in your mind. What is head 1? It is P1. What is head 2? It is P2. What is head 3? It is the result. So if coefficient not equal to 0, what you will do? Attach coefficient comma A exponent comma head 3. So next you write A is equal to A then link, B is equal to B then link. So that is similar to what you write, P1 is equal to P1 then next. So instead of next, here you are going with link. Okay. So if A is greater than B, that means, so you take it P1 is greater than, sorry, if P1 is greater than P2. So this is the case. So if P1 is nothing but what? If P1 is greater than P2, you go with A. So here you can take that it is P1. And here you can take it, it is P2. Okay. So if A is greater than B, what you will do? So you will take A. So attach A then coefficient, A then exponent, head 3. So the hot now you go with A then link. So similarly, else part means if A exponent is less than B exponent, that is P1 is less than P2. So at that time you go with a P2. So P2 is nothing but B coefficient, B exponent. So here you consider with P1 greater than P2 is equal to P1. So here P1 less than P2 is equal to P2. So P1 is nothing but A, P2 is nothing but B. Okay. So if you want to move further, now you come for the next one. So here we have taken it as P1 then next and P2 then next. Here we take it as P1 is nothing but what? A. A not equal to head 1 and B not equal to head 2. So what you will do? Attach A coefficient A head 3 and B not equal to head B coefficient you will take. So this is the program on C code, C function to add two polynomials with a header node. Understood? So now you come for the next one, multiplication of the polynomial. So how you multiply the polynomial? So in this approach, we will multiply the second polynomial with each term of the first polynomial. So keep in your mind, we multiply the second polynomial with each term of the first polynomial and store the multiplied value in new linked list. Then we will add the coefficients having the power in resultant polynomial. So keep this one concept in your mind, how you multiply. In this, we will multiply the second polynomial with each term of the first polynomial. So this one is first, this one is second. Here we multiply the second polynomial with each term of the first polynomial. So 4x into 5x square. 4 5s are 20. X into x square, we call it as x cube. Next, we take it as 4 into minus 2x. So 4 into minus 2, minus 8, x into x square, plus 4 into minus 1 will give you minus 4x. Understood? Now you multiply 4 with all the numbers. Now you multiply minus 3 with all the numbers. So minus 3 into 5x square will give you minus 15x square. Minus 3 into minus 6x will give you minus into minus plus 6x, and minus 3 into minus 1 will give you 3. Okay, so when you multiply, now you see, so 20x power 3 plus minus 8x power 2 plus minus 4x. So when you add this will be the statement. Okay, so this is up to multiplication of the polynomials. So now you see, you can write this too. First comes 20x power 3, 8x square, 4x, next 15x square, 6x and 3. So which are having the power same, you add that thing. So 20x power 3, next you get squares. So minus x minus 8x square plus minus 15x square plus minus 4x plus 6x plus 3. So when you add each and everything, minus 8 plus minus 15. Minus 8 minus 15 will get you minus 23x square. Minus 4 plus 2 will get you 2x plus 3. So this is the value what you will get when you multiply polynomial. So what you will do? We multiply the second polynomial with each term of the first polynomial and store it in a new linked list. So that's why we give it as this representation. Understood? So up to here, have you understood? So this is up to using polynomials in representation of linked list. So that is the first application, that is Rook's polynomial. So you can have the word polynomial using linked list. So this is up to this today's class. So